the exam today? Good, bad. How many will be getting 0? Based on that I decide something. Any hands please, who will get 0? Or who could not write much? How many hands are there? Because of that I will see what can be done. That's what I give you a favor. How many guys will be getting almost tending to 0? Not 0. Next question. So that means all of you are getting 15 out of 15 or 20 out of 20? Okay. How many guys will expect more than 10? Okay. 1, 2, 3, 4, 5, 6, okay. How many guys are getting between 5 and 10? Rest of that is okay. Okay. Thing is that I have the question paper copy with me. Already you have submitted your copy to me. First question was very straightforward. That macro matrix was given, right? And you have to construct a set of independent reactions for the system. You need to have the null space. Okay? What I will do, I will say the null space basis. The null space basis is correct, I will give 2 marks. Even the reaction mechanism is wrong. But if the null space basis is wrong, you will get 0. There is no problem. Anda is clear. Okay. So 5 points are there. So now we can decide how much you get. If null space basis is correct, the mechanism is wrong, I will see I may deduct maximum 1 mark or something, but part marking will be there. 80%, 90% marks you will get. Because the null space basis is correct. But if the null space basis is wrong, you will get 0. Any question here? Ask the question. I am giving you estimate how much you get, so that you will have the idea when we will come back. Any questions from your side? No questions, right? Second question was determinant of that data is given. That formula you have to apply. And this question was given from assignment, right? Yes. Okay. And what you have to do, you have to do some row operation first. After that, we will get a cubed expression. And with that, even you don't have to apply the formula also, you can directly get it. That forms the guidelines. You can apply the formula also, no problem. But if you apply the formula, your credit will be given fully. If you don't apply the formula, your credit will be partial. Okay? Right? So because it's a n by n, I will be expecting all the steps. That means we are skipping the steps. Okay? Even a diagonal matrix, you can prove the diagonal matrix's determinant is the multiplication of all the leading diagonal. How will you get it? Based on the formula. -1 whole to the power h, a1, k1, a2, k2, an, kn. And every time 1 0 will be there, except one term. That's why you can get that particular formula. Okay. So if that step is not there, how much marks I will give out of 4? You tell me. 1 mark I will give. Somebody said 1 mark. Okay. So I will give 1 mark if that step is not there. Some of you said only 1 mark. Okay. I will give 2 marks. Okay. There is average. Somebody said 1, somebody said 3. 1 plus 3 divided by 2 is 2 only. Okay. So I will give 2 marks because already 1 mark was told by somebody. 3 marks was told by somebody. Average is 2. So if that step is not there, I will give 2 out of 4. Okay. Any questions there? Okay. What question? You wanted 3, huh?
Yes, sir.
Okay, I will see whether 3 can be given. Based on the population in the course, how the people actually. If I am happy in the class performance, definitely I will give 3. If my mood is off, see what actually happens, how I grade the questions. First I will see all question 1, all 66 answer sheet. I will come back again the first problem, start doing the second question. Then I will come back to the third question and start doing the grading. If my mood is good after the first question, I will be giving 3 out of 4. My mood is bad after first question, I cannot give you guarantee. Understood? Because the mood also depends. No? Because I mood will completely off and all, then I will be crying and all, then things will be very bad. Okay. Next is, given that 2 Hermitian operators A and B commute. You understand that question, right? And A phi I equals to lambda I phi I. What can you conclude about eigenvalues and eigenvectors of B? Any of you got it? How many of you got it? Nobody. So that these 3 marks generally people will not get. So I am expecting highest to be 17. Right? Okay. Third question was already given in the class. Only I changed the values. 3 d2y dt square plus 5 dy dt. Vasudha, can you please write the question because I am expecting the model answer from you on Monday. 3 d2y dt square plus 5 dy dt plus 2y equals to 0 with boundary conditions y t equal to 0 equals to 1 and dy dt at t equal to 0 equal to 0. Obtain solutions for y and dy dt done by the class principle based on eigenvalues and eigenvectors only written also. If you do something else, that's why I wrote only, because if I don't write only, somebody can go to court and court can give me an order to give the marks, because I am very, very careful. Because many times I came into this problem, people are threatening me that, threatening me I go to court and all. I am very much afraid, because court means I have to go some other place if my case is lost. That's why I put only here. You see that? So only means, now that see English wise, you have to be very careful. So this only is written here. That means if somebody does something, what marks I should give? 0. Yeah, some of my friends. So you are really knowledgeable in that way. I really appreciate it. Somebody does something means I will give 0 only. 0 only again I am saying. 0 only because only is written here. Okay. Next question was, so you know your marks. See, point is, I want the crispy answer. Answer you know. Vasudha will give the answer to me, the full derivation. If you want, you can see what are the things, eigenvectors and what you got. There is no part marking here. I will see the final answer. If it is not there, straightforward and small 0 will be given to you. I will not give big 0. Small 0 will be given to you. So these 6 marks will be decided by you only. I cannot do anything here. Okay. How many of you got it correctly in hands? 1, 2 only. So many of the guys will be getting 0 here. I guess correct? Okay. Very good. Plot the solution. You are too early for the next class. Okay. I will see you on Tuesday. All the best. Plot the solution y with time so that in bracket Vasudha t equals to 0, 1, 5, 10 and infinity, and obtain a steady state solution based on your graph analytical solution. What's the steady state solution? 0. Excellent. And how it will proceed? Did you draw the graph? Okay. Yeah, you are sketching it fine, because since my drawing is bad, because engineering is drawing, I used to get only C or D grade. Since I am a bad, my knowledge is bad, I will excuse here. If your drawing is bad, I will excuse. And if I see your drawing is approaching the reasonable value, I will give 2 out of 2.
Even the sketch is qualitatively right.
No problem. Because since my engineering drawing is, since I used to get C or D, I will excuse that, because I am not a... See, point is, if I am good, then I will expect. If I am bad, of course you can be bad, no problem. But mathematics is not applicable there, because mathematics I don't think I am that bad. Okay. So, but these 2 marks are a problem. Point is, if you don't get the first part, you won't get the second part. Okay. Or, I will tell you how to get these 2 marks. Because I will go by the court order. Because here I didn't say only. Only thing is, I have said, yes, solution based on your graph and analytical solution in A. So one person can do by the graph, solution they can do by the old technique. First part they may get 0, second part they should get 1, not 2. Because one by a graph and one by analytical solution in A. Analytical solution in A means, in the A part, solution has to be done by the analytical solution. If that is not done, analytical part will not be considered. Only graphical part will be considered. So, if the graph has been drawn correctly, analytical solution is wrong, only 1 mark is given. I am going by the court order only. What is written here? Any question? So, first question you know that the null space is correct, you get 5 marks. If null space basis is wrong, not 5 marks, 4 marks or something, I will decide. It is not, I have not decided how much marks I will give if the reaction mechanism is wrong. Second question, derivation wise we have decided we will be giving 3 out of 4 if that particular, because we have given the definition of determinant that has to be used. So 3 out of 4 will be given. If the entire thing is wrong, no part marking, 0. Okay, and the 2B, generally you are getting 0, right? Because you have not attempted. You have attempted. So you want some part marking for that?
Yes. Yes, sir.
How many of you guys attempted? Okay, I will see that so many guys attempted, so I cannot give part mark. If only you are attempting, then I will see. Okay, so the rule is that I cannot give part mark because you have to give, unless this is correct, I should give 0, unless exceptional case. So first question you are getting 5, I am assuming. Second question you are getting 3, 5 plus 3, 8. And third question, if you get 6 marks, you should get 14, and plus 2 you can easily get. You get. So I can assume that 16 marks are actually coming easily out of 20, right? 16 marks. So if you get 16 out of 20, your chance is going to getting S grade is also very straightforward, because you are already having 80%. Because S grade is generally given after beyond 75% in the course. So that is the situation now. But the people who are getting 65-70%, they should not lose hope because another 2 exams are there. I remember once one person got 15 out of 20, got C grade because he thought he already got S grade. He did his study in the second quiz and end semester. So he did very badly, and finally he got B or C. One person got 7 out of 20 once and got A grade in the second and third quiz. But that is very rare. You should not take the second example. First example is very easy to form. Okay. So you understood the marking policy. Because when I give the answer sheet, I won't discuss the marking policy directly. I will do that, and you will be expecting how much marks you will be getting, and similar marks you can actually expect. Since there is no part marking, there is nothing much to think about. And some of you might not have got any answer, so you will be getting 0 only. How many people didn't get any answer correctly? Any hands, please? No hands. Okay, that means I should expect at least 10 marks or something out of you guys. Did you get answers correctly? Or how many questions you got the answer correctly? All questions.
So second part you are
So given the poor mission matrix, that one you got correctly. Okay, and then third question, did you do it correctly? So that you will be getting 8 points there. No, you know the answer. No, answer you know that. How to get the answer? Because we have already done your this thing. No? This is from the 10 plus to calculus. From 10 plus to calculus, you know the answer. The answer is no. Only the technique is different. Okay. Then you have to see the eigenvalue, eigenvector, and all the steps have to be there. If the steps are not there, I cannot give the whole marks. So many things are actually there. So we will see how things will evolve and think. And any feedback from your side, the questions and all. So the next quiz you can see, you can consider your feedback. Questions, what is the difficulty you faced? Huh? What is that? Is it okay? Because whatever I taught in the class I get. There should not be any complaint. And things mostly came from the assignment, right? And whatever hints I have given, it is also coming. I think same style I should follow, right? Vasudha, any feedback from your side? How was the exam? How much you are getting? You will be getting now your estimate. 17 is a good one. 17 you are expecting. Okay, you know all the answers. First question you are getting 5. Last question you are getting 8, 13. And next in between you are getting 3 or 4, right? The second question. Second question will be deciding factor. Because if you are doing routine wise the notes, from notes if you close the eyes, 13 marks is given. 5 plus 8. That is guaranteed. Only second question will be deciding how much will be difference from the one person other person. But point is, some people will be doing terribly bad in first and third question also. For those people you don't know what will happen. 13 marks I have given just like that out of 20, which is 65%. If you maintain 65%, you will be possibly getting A grade, which is discipline. That means getting A grade is very easy if you follow the notes. Okay? Getting S grade is slightly difficult. That is the thing. But getting E grade also very easy because you don't have much time to follow the notes. And getting A grade is also E grade is easy because I am not giving you grade. Because my cutoff of E grade is how much, tell me? decide the cutoff for E grade. I will decide the cutoff for E grade. How much is the E grade cutoff? How much is the E grade cutoff? Because I am giving you a promise that I am not giving you. It's a good promise, right? That means nobody will fail. So in that case, how much should be my cutoff for E grade? Out of 100 I am talking about. What is happening? What's the 40? Are you mad or what? Or you want to keep your classmates? I think you have a lot of enemies in the class. I think you want to keep your classmates. My God. I will not have this kind of classmates in my class. My classmates are better than you. In fact, I am better than you actually. I will not give 40 as cutoff for E grade. Any other suggestions? He's a dangerous guy, please be careful. If he wants to kill you. Huh? 10. Okay, 10 is actually a bit difficult to give because anybody can get 10. You know why? Attendance is 10. Right? Because I may be going to quote again if I quote 10. Why? Then I will tell you why. Some of your classmates may try to teach me a lesson. They will not write anything in the class. First quiz 0, second quiz 0, end semester 0. Okay? But he will attend all the class. And then he will find a court case. Such a course actually is happening in IIT Madras. You can easily pass if you don't write anything. Then next day I will be going to, you know which place, jail. So 10 is not a good idea. So what madam is trying to do, trying to put me in jail. So that is also not correct. So what I will do, slightly modify, I will put 40. My distribution is, quiz 1 you get 1 mark, quiz 2 1 mark, end semester 2 marks. Possible, right? If you get this 1 plus 1 plus 2, 10 marks attendance, you are getting pass grade. Is it okay? Yeah? Acceptable, right? Yeah. So it is difficult to fail. But I am telling you that, yeah, thing is that in this context, when I was teaching a BTech class, what actually happened, one of the first Thursdays I was teaching process calculations. I told you again and again this story, that I also was very liberal. But those days I was putting 17 was the cutoff, slightly higher. That guy came one day to me, he said, I will fail the course. I said, you cannot fail. He said, bet. I said, fine. First exam he wrote questions, he got 0. Second exam he wrote questions. Third exam he was very afraid, he didn't come to the exam. That 10th semester, and he got the U grade. So this is the only way you can get the U grade. Okay? So some people may get 0 in quiz 1, should not be afraid. Second quiz you write something, I am advising, so that I can give 2 marks. 1.5 also okay. What I can do, if you get 13.5, I can push to 14 also. Okay? So quiz 2, try to write something so that I can give 1.5. And end semester I can also give you some 2 marks so that I can adjust to 14. So I am giving you some idea here to pass. Okay? So I think getting pass grade is not that difficult. It's easy only, right? So I think you should be happy. So people will be expecting 0 marks here, not to worry about. But the point is, this is not a good news for MS and PhD students. For the MS and PhD, we have to get minimum C grade. Okay, that's the problem. So E grade is sufficient for MTech people. MTech must be very happy here. But the MS and PhD, we have to get minimum C grade. And there is a problem. Because C grade is cut off very, very high. So maybe it may go like this, 75, 65, 55, 45, S, A, B, C. So 45 means, and that too, you cannot be assured that in attendance always are getting 10 marks. So here also I'm assuming attendance are getting 10 marks. Attendance you get 7 marks. Then we have to get another 7 marks to get E grade. Again it will be difficult. So in that case I have to really work hard how to get E grade. That is the question mark, then I will decide. Then I will discuss with individual people how to work on it. But try to get 10 marks here. Okay? So here also, if you lose marks here, Then my friends found I told, I will tell you. Last year, one guy was very smart. He did not attend all the class. He got 7 marks. His quiz 1, quiz 2 are very good. Instead of S grade, he got A grade and he missed by 2 marks. Then he came to me, sir, I missed S grade for 2 marks. And he thought I would be very sympathetic to give him S grade. I saw his attendance mark was 7. I told boss, if you attended all the classes, you have got 10 marks, then you have been well ahead of S grade. So in that case, I won't be sympathetic. Generally, 2 marks will be there in my hand. Remember that. I can give 2 marks grace. If I see you are getting 63, I can do 65. But that is not true for all the cases. If I see you are not attending the classes, all classes, that 2 marks I will not give because I cannot justify. So only 2 marks will be there in my hand. Okay? Similarly, if somebody gets 12 marks here, I can still give 2 marks here and there. But something should be written there in the answer sheet. If nothing is written, I cannot give that 2 marks. Okay? So 2 marks in my hand. So I am giving this much discount to you. Okay? Don't ask for 3 marks. 3 marks is not my hand. Only 2 marks. Okay? Any questions? Okay, so everything is clear. So let's look at, we are doing so many things plus. We have found that we wanted to solve dx dt equals to ax, and we have there are fast techniques. Fast techniques, what we have done, we have used the eigenvalues and eigenvector decomposition. First few problems, example problems. What we did, we actually found the eigenvalues, distinct eigenvectors, and got the expansion solution. Then it is possible to convert this A matrix to diagonal matrix, and you get a separate differential equation. And I showed you, if this matrix is diagonal matrix, it is possible to solve the problem easily. Okay? Because we can directly get the solution in one shot. Okay? So with that, we have the relationship between A and lambda matrix, which is P inverse AP, which is your lambda matrix, right? P inverse AP is your lambda matrix. Am I correct? Yes or no? Okay. And if I am having distinct eigenvalues, lambda 1, lambda 2, lambda n, your lambda matrix or the diagonal matrix is given as lambda 1, lambda 2, lambda n, this is 0 and this is 0. Okay? So this much we have done. And this is straightforward. If your matrix A is symmetric, the straightforward in the matrix A is symmetric, because in that case we know that even for the repeated eigenvalues we will get orthogonal or ortho-non eigenvectors. So before proceeding further, I want to take one example problem. Write down the matrix 1, 2, 2, 1. Write the matrix 1, 2, 2, 1. Matrix 1, 2, 2, 1. Verify P inverse AP equal to lambda. First you find out eigenvalue, eigenvector and verify. First you find eigenvalue, eigenvector and verify. Eigenvalue, eigenvector and verify. What are the eigenvalues? What is that? Minus 1? Minus 1 and 3. Minus 1 and 3 are the eigenvalues and eigenvectors. And remember this matrix is symmetric. This matrix is symmetric. This matrix is symmetric. This matrix is symmetric. My eigenvectors, first eigenvectors and second eigenvector. What are the eigenvectors? First eigenvector?
Minus 1, 1.
Minus 1?
1.
Minus 1, 1. Second eigenvector? 1, 1. Okay. What is P inverse? Okay, P matrix. What is P matrix? Minus 1, 1, 1, 1. P inverse.
Minus 1.
How to find P inverse? You know that. How to find from here P inverse? I want a shortcut method. When P inverse equal to P transpose? Orthonormal set, right? What is the length of this eigenvector? The square root of 2. It is square root of 2 again. So 1 by root 2. So you can tell me the answer. So it will be P transpose if those eigenvectors are orthonormal. So what will be my answer then? What will be my answer then? What will be my answer? P inverse. What is that? Remember that your P is not orthonormal. P inverse and P transpose, I have given the relationship yesterday. Not yesterday, for last year. Yesterday I have given the relationship. P inverse and P transpose relationship is there. P inverse, P transpose relationship is there. I have given the relationship last class. Yes.
Diagonal matrix of eigenvalues inverse of.
We can tell me in terms of rows or columns. 1 by root 2 will be there. It will be 1 by root 2 because remember that if P inverse will be P transpose, if original matrix would have been formed with orthonormal eigenvector, but original matrix is not formed with orthonormal eigenvectors, so we cannot get squeezing. But then the relationship between P inverse is going to P transpose. We have done in terms of inner product last class. You apply that and what you will get. Remember that if it is minus 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2, I agree with you. This is not the case here because if you look at this eigenvector, they are orthogonal, but they are not orthonormal. Okay? Original P matrix should be such that the column vectors, orthonormal eigenvectors, then you can say P inverse equals to P transpose, right? Otherwise you cannot say. But there is a relationship between P inverse and P transpose for any orthogonal system. That thing has been covered yesterday. You don't have that notes, yesterday's note. If you look at me or look at the board, nothing you will get. You should not be lazy. I am now favoring here because I want to solve a problem what we discussed yesterday. I am favoring you here. How much is P? How much will P inverse? What is that? What is P inverse? I want the entries.
Minus 1 by
Root 2 is coming. I think you are not following what I said. If P is formed with orthonormal eigenvectors, then P inverse is going to P transpose. Are these eigenvectors orthonormal? No, then how can you say 1 by root 2? They are not orthonormal, right? Then you can change the row to column, you can get it. But you cannot get it. It is not orthonormal set. And there is a relationship between P inverse and P transpose. Yesterday I talked. I don't think you have a time. You can look into it. You see the P inverse matrix. It is given U11 by inner product U11, U12 by inner product these things, and similarly U12 by inner product U22. All are given. You only told me, I forgot your name. You only told me you should be taking it out. If you take it out, what you will get? Yesterday I discussed that one. It will come in one step. I am really surprised this one step process is not coming. This one step process.
So minus 1 by 2. Minus 1 by 2.
Minus
1 by 2.
If I put half here, then how much is coming?
Minus 1.
Minus 1, 1.
Yes.
1, 1. Minus 1 should not come here. Why you are saying minus? Because you will be taking inner product things outside. For the first row, you will take U1, U1. From second row, U2, U2. If you multiply root 2 into root 2, you will get half. And then other things are same. Minus 1, 1, 1, 1. relationship yesterday, right? Is it following the relationship? Okay. So P inverse is obtained. So now P inverse AP is what? P inverse AP.
Lambda is diagonal of lambda.
So you get the eigenvalues are obtained as lambda equals to -1 and 3. Right? So it means -1, 0, 0, 0. Right? So this is your diagonal matrix. Okay? For a diagonal matrix, what are the eigenvectors? See, very interesting thing I am going to address here. This matrix and this matrix have the same eigenvalues. This is having -1, 3. This is also having -1, 3. Do they have same eigenvectors? Do they have same eigenvectors? What are the eigenvectors? Any diagonal matrix, what are the eigenvectors? Let's look at it. Let me ask you a very fundamental question. I am giving one diagonal matrix. 1, 0, 0, 1. This is a dangerous matrix and put 2. Because this matrix is a special case, eigenvalues are repeated. Identity matrix is such an interesting matrix whose eigenvalues are repeated, but since that represents symmetric system, which you should get orthonormal system of eigenvector. How will you prove? I will come next. I am asking for this case, what are the eigenvectors? How will you get minus lambda u1, sorry, you can say u1 u2 0 0. What do you get? You get
Plus lambda square.
so lambda equals to 1 and 2. If I say lambda equals to 1, you get 0 0 0 1. u1 u2 equals to 0 0. You will have 0 1 0 into u1 0 into u2 equals to 0 0 plus u2 into 1 equals to 0, and then u2 must be 0 and u1 could be anything. U1 could be anything, right? U1, if u1 is 5, no problem. So I will say simplified case u1, and it belongs to null space because well, you can see that this is having 0 row, that means this is the independent equation, the dependent equation. You can flip it. So this, of course, rank of this matrix should not go out of the matrix because we know that determinant of A minus lambda has to be 0, and that shows that it has only one row. Okay, so this is the independent row. Okay, so that means if I fix up u2, u1 is automatically fixed and u1 could be anything, and that's it. So it is alpha 1 0. Yeah, alpha 1 0. So for this case, one eigenvector is 1 0. Similarly, if you put 2, you will get what eigenvectors? This is the first eigenvector. Second eigenvector will be 0 1. I don't think I have to prove it. Okay. So one good thing is, if I have 1 0 0 2, the eigenvectors are the coordinate axis. Okay. So we can say that geometric basis, that means coordinate axis, will be the eigenvectors when your matrix is a diagonal matrix. Now, if your matrix is an identity matrix, what will happen? Matrix A is an identity matrix 1 0 0 1. Lambda is 1 and 1. Lambda is 1 and 1. That means what equation you are getting? You are getting 0 into u1 plus 0 into u2 equal to 0. Okay? What it shows? It shows, I will see how you get two independent eigenvectors. This is a case of symmetric matrix, right? The symmetric matrix but diagonal. Your system is, you are lucky that I didn't give this question. Again, all people will get failure. I simple question I could have given you today. Matrix is 1 0 0 1. Find two independent eigenvectors. Simple. 5 marks, finished. Question is very good. I will say my matrix, the identity matrix, people cannot even complain. The simplest matrix 2 by 2. You cannot even simple matrix. I will ask you, find eigenvectors. How to find two orthonormal eigenvectors? My eigenvector values are, we cannot argue on that. Because lambda minus 1 whole square equal to 0. Lambda has to be 1 and 1. How to find two independent eigenvectors? If I put, so my eigenvector equation is, am I correct? What do you get? 0, 0, 0, 0, u1, u2 equals to 0, 0. Maybe for your juniors I will give this question. You will be coming next year. 5 marks. That's it. Next, tell me how to find two independent eigenvectors. See, such a simple system, you have to really think about it. How to get two independent eigenvectors? Huh? How to find dimension of null space? How to find dimension of null space? How many number of independent equations? What's the rank of the matrix? 0. Rank of the matrix 0. Oh. 1, 1, 1. I have got 3 answers. 0, 1 and 2. 1, 1, 1, 1. 0 also somebody told. How many people are saying 0? Only you are saying 0, right? Why not it is 0? What is rank of the matrix? What's the rank of the matrix? See, I am going more fundamental. See, now you see how you are struggling to get the eigenvalue of this problem. You are struggling to get eigenvalue of this problem. How many non-zero rows are there? 2. Okay. What is the rank of the matrix then? Non-zero rows are 2. Huh? I think you are completely confused. I am talking about this matrix, boss. This is non-zero row? This is non-zero row, I am asking. I am saying only 0, 0, no? No, don't say something else. Is it 0 or something else? If you say 10, I will surrender and go. So it is 10, I will surrender. And go nonsense. Why to teach mathematics? Now I am really confused. You are not able to differentiate 0 and other number. If somebody told me long back, so what's the difference of 1? If you put 1, this streak will become 10. He wanted to increase his marks. I said if you remove it, it will become 0. So if you talk like this, I cannot have any answer. I don't think it is 10, right? You are seeing my handwriting is bad, but it is not that bad. It is 0, right? It is visible. So is it 0 or non-zero row? Non-zero row, he is saying. See, I don't understand why you are saying non-zero. 0. Is it what? 0. So how many non-zero rows you have? 0. What is rank of the matrix? See, I don't know what I should do. I should cry or laugh. I don't know. Your answer is actually making me, I cannot get angry because there is no point. I can only laugh. How many non-zero rows are there? He said 1. Why 1? You only said 1. You only said 1, no? Yeah, why 1? Can you explain? No, yeah, it is, I am helping you. See how you are struggling. I am only asking you to find out the eigenvector for this matrix, and this much struggle is going on. How many non-zero rows are there? 0. How many non-zero rows are there? 0. Rank of the matrix is 0. So, what will dimension of null space? 2. Dimension of null space is 2. That means so rank of the matrix will say that I don't have any equals of independent algebraic equations. Okay? I don't have any information on the independent algebraic equations. That means I am having 2 unknowns. System, you just imagine, I have 2 unknowns, x and y. No relationship, nothing will be possible. Nothing is possible. Okay? So in that case, if it is nothing, so I can have basis set 1, 0 and 0, 1. Simplest. I am having 2 variables. They said no relationship, we don't know. Anything is possible. That means what? You are saying x plus y equals to 2. You are saying at least this relationship is valid. Yeah, that means I am saying if x is 1, y could be 1. If x is 1.5, y could be 0.5. So, in that way, it is also saying anything is possible, but all the time, x and y satisfy 2. But here, no such relation is available. Anything is possible. That means, simplest thing is 1, 0 and 0, 1. Because, if you look at the equation, what you got? 0 into u1 plus 0 into u2 equals to 0. You can have basis 1, 2, 2, 1 also. Okay? Doesn't matter. So what actually happened in that? So this belongs to the solution alpha into 1, 0, beta into 0, 1. Okay? So that's the way you get still orthonormal eigenvector possibility. Okay? Simplest cases. Funda is there. So what you see now, the question is when you have a matrix for this case, what are your eigenvectors? Minus 1, 1 and 1, 1. What's the angle between them? These eigenvectors. How to find out the angle? Inner product, which is becoming 0. So they are perpendicular. Okay. So if you draw the eigenvectors, which is first eigenvector is minus 1, 1. This point. This is the first eigenvector. Second eigenvector is 1, 1. This is 1 and this is, so it is, sorry, I have done something wrong. I'm sorry. This is minus 1, 1, right? Yes? Okay. This is 1, 1. These two are real eigenvectors. If you diagonalize, this is your 1, 0. This is your 0, 1. So still, this orthogonality is maintained. That means what? When you diagonalize, eigenvectors will rotate without affecting the angle. Okay? So eigenvectors will rotate. So you already have eigenvector, and when you do diagonalize, your eigenvectors will coincide with the coordinate axis. So this is the way the diagonalization means. That means eigenvalues will not be affected, eigenvectors will change the orientation. Advantage is, if you do diagonalize, your geometric axes are the eigenvectors. And as I said, if you have the eigenvectors, which are the best basis vectors, and if geometric axis and eigenvectors excellent, we can get a solution very quickly. Any question there? This concept? This is not any of the books. Okay. So many things have been done here. Now, we are going to some other concept. We are going to the stuff where you don't have symmetric matrix. We have non-symmetric matrix, and top of that, some eigenvalues are repeated. See, non-symmetric matrix, the eigenvalues are not repeated. Still, these methods are valid because you can do gram-Schmidt orthonormalization, get orthogonal eigenvectors, and with orthogonal eigenvectors, you can get this type of system. Now I am going to a worst situation where eigenvalues are repeated and non-symmetric. So very bad situation. So I am going to a system. We have, I am going to a system non-symmetric and repeated eigenvalues. What will happen? Eigenvectors are not linearly independent. G, E, V may occur Generalized eigenvalues vectors more. Worst case. For this case, whatever numerical problems we discussed, that first method will fail. Remember that we discussed A going to B, B going to C. So many problems we discussed. One control problem also we have discussed. Luckily, they are giving it a repeat eigenvalues. If repeat eigenvalues are occurring, that particular method will fail. How to solve this kind of system? Question is how to solve this type of system. dx dt equals to x. Okay? dx dt equals to x. A matrix is non-symmetric, having repeated eigenvalue. Matrix P inverse AP. How does it look like? Will it be diagonal matrix? What is your comment? Will it be diagonal matrix for this kind of system? What you can expect? You cannot expect anything. Very good answer. He said he doesn't expect anything. But I will say that what you can expect, you will get a new matrix called Jordan matrix. You will get something called Jordan matrix. Okay? This Jordan matrix I will discuss now Jordan block and then we will talk about the P inverse AP and all for the non-symmetric case. This Jordan matrix is having beautiful construction. You will have sharp Jordan matrix. It will consist of sharp Jordan matrix and 0. Remember that there are small matrices inside. That matrix could be 1 by 1 matrix, could be 2 by 2, could be 3 by 3, could be 4 by 4, could be 5 by 5, could be anything. If 1 by 1 matrix J1 is nothing but lambda, only one into eigenvalue. J2, so J1 is a matrix 1 by 1, J2 is 2 by 2. What will actually happen? Now the Jordan block definition I am addressing here. Jordan matrix or Jordan block of order M is like a Jordan block of order M associated with lambda. The Jordan block of order M associated with lambda is an M by M upper triangular matrix with lambda. A Jordan block of order M associated with lambda is an M by M upper triangular matrix with lambda on the diagonal, comma, once ONES, that means once on the first super diagonal, once on the first super diagonal, and zeros elsewhere. I will repeat once again. The Jordan block of order M associated with lambda is an M by M upper triangular matrix with lambda on the diagonal, once on the first super diagonal, and zeros elsewhere. That means what will be my construction for J2? Excellent, you understood. Okay, this is 2 by 2. J3, it is 2 by 3, I am saying. It could be 1 by 1 also. I am just putting 3 by 3. J3 will be lambda, all same eigenvalues. A particular block, eigenvalues will be same. Okay, particular block, eigenvalues will be same.